Welcome to the knowledge sharing sections. I am Dr. Dhanabalan, Professor, Department of Mechanical Engineering, M. Kumarasamy College of Engineering, Karur. So I have attended the 5 days FDP in N83C in the topic of additive manufacturing and applications in industry premises. In additive manufacturing is a recent trend to manufacturing all kind of components with less wastage. In the topic or rapid prototyping, tooling manufacturing, 3D printing, so additive manufacturing, popular process of 3D printing, case studies, Industry 4.0, sustainable additive manufacturing, 4D printing, design and additive manufacturing, topology optimization, generating. So these are the topic we are discussed today. So in this flowchart we are able to understand how the additive manufacturing work like. Actually the component were designed by using CAD. Then CAD, each and components are split into so many segments, then feed into that machining. Based on these images, the product was developed by additive manufacturing process. In this basic of process, 3 stages: pre-processing, building and post-processing. Pre-processing nothing but, so before going to make a product, some process we are done. This is called pre-processing. So it's been modeling taught by CAD, then converted into STL file, then slicing by various segments, then convert into building type. Okay, then any suppose this post process, then cleaning, post cure if needed, are applied, then parts is completed. So these are all some basic process of modeling. So from this slide you are able to understand fusion deposit modeling. Actually the additive manufacturing, the fusion deposit modeling is this wire was shown in the images. We are using some PVC wire. In that, based on the diagram created by CAD modeling and sliced into so many segments, so based on this wire were fused and deposited over a platform base. Okay, then once the final products are obtained, entire process will be stopped. So in this process only the less wastage of metal was used. Normally in conventional manufacturing process, during machining, so many wastage are there. To avoid these things, this kind of additive manufacturing is utilized in various premises. Stereographic process, in this case actually in the we are using liquid resins. The liquid resins are filled with basin as shown in the image. Then we are passing a laser light through a focusing system. Then it curing the liquid resins. Then the cured resins were deposited in the platform. Okay, each and every layer were deposited, and the platform move downwards as shown in the image. Finally the products was completed, then the process will be stopped. Here the applications of this process: rapid prototyping, mold for tool and metal casting, hearing aids and medical implants, so dental restorations, jewelry castings, automotive components, aerospace components. So selective laser sintering. So in this, similar to the laser sintering process, here the sheets are used for fabrication. As shown in the image, the sheets are traveled in between the chamber. Okay, then you have a CO2 laser. That lasers curing based upon the sliced images. Okay, then for one layer were created, immediately this will deposited in the platform. Okay, then the platform moves downwards. Next, the fresh sheets are coated over this to cut the next layer. So each and every slits have a less thickness. Okay, this range is a very nano level deposition will be. In this layer, CO2 layers are used. Deposit new layer by powder above previous layers. Each and every time shake away surrounding powder, reused. So back model in over to sinter. So diffuse lower MP, fill porous. So in the same images, So using some X-ray scanner, the laser, the metal powders are cured by using applies laser. Then finally the products were created by this process. So in this area, applications of 3D printing, tissue engineering, automotive applications, mechanical jewelry and tooling, medical, building constructions, aerospace applications, toys, food industry and defenses. In 4.0, 4.0, there's a recent trends in additive manufacturing. As only the images, the industrial revolutions are move on to 4.0. So need of industry 4.0 is, well, it is self-learning to improve the overall performance and maintenance management with surrounding interactions. So it aims to construction of an open smart manufacturing platform for an industrial network information applications. So real-time monitoring, tracking the status and positions of product as well as hold the instruction to control production process and the main need of industry. So benefit of 4.0, it helps the manufacturer with current challenges by becoming more flexible, making reacting challenges in this market easier. It can increase the speed of innovations and very consumer centered, leading to faster design process. So work can become a coordinator and the center of productions, possibly improving the work file balance employees. Its benefit, high revenues, increasing profitability, flexibility and agility. This then creation innovative opportunities. Outcome of industry 4.1 by additive manufacturing. So this technique we are followed in industrial 4.0. Started with cyber physical crimes, then industrial internet of thinking, horizontal and vertical system, simulations, autonomous robots, biodata analysis, augmented reality, additive manufacturing. So these are all some components in industrial 4.0 to increase the productivity of any industries. Let's discuss it one by one. Well, cyber physical system, it's a collaborative computational element controlling physical entities. CPS are physical and engineered system whose operations are monitored, coordinated, controlled and integrated by a computing and communications core. Then biodata next, biodata analytics. So biodata refer to large set of structured, unstructured data that can be compiled, stored, organized and analyzed to reveal patterns, trends, association and opportunities. As per Forbes, biodata is a collection of data from traditional and digital source inside and outside company that represent source of ongoing discovery and analysis. Today data is collected everywhere from system and sensor to mobile devices. Horizontal and vertical system. So from operating purpose perspective, the horizontally integrated companies focus its activities around its core competencies and establish partners to build out of end-to-end value chain. The vertically integrated company, that other hand, keeps as much its value chain in-house as it can from product development to manufacturing, marketing, sales and distributions. So additive manufacturing, so 3D printing is transformative approach industrial production that enables creation of lighter, stronger parts and systems. It yet another technological advancement made possible by transition from analog to digital process in recent decades. Communications, imaging, architect, engineering has undergone the digital revolutions. Now AM can bring digital flexibility and efficiency to manufacturing operations. Then industrial Internet of Things. So IIoT is the issues of smart sensor and actuator to enhance manufacturing and industrial process. Also known as the Industry Internet of Industry 4.0, IIoT leverages the power of smart mechanics and real-time analytics to take advantage of the data thumb machines have produced in industrial setting for years. So industrial shown in the images. So augmented reality, it's an interactive experience of a real-world environment where the objects that reside in the real world are enhanced by computer-generated purposeful information, sometimes across multiple sensory modalities. With the help of advanced AI technology, the information about surrounding real world the user become interactive and digitally manipulated. which are virtual reality, it will playing a leading role 4.0. It's open various avenues to develop innovative solutions as manufacturing unit equip with themselves the smart machines, high connectivity, data intelligence platforms, and simulations tool.